Hey, welcome to this video. Let's talk about error/loss. So quick review. During training, let's say we have a model that tries to predict between if this is a picture of a cat or a picture of a dog. They'll make a prediction, and then we will use the error/loss to tell the model if its prediction is correct or incorrect. That error/loss is used to update the weights. Hopefully we get better weights that makes better predictions. Ultimately, we want weights that minimize the error/loss. A pretty easy error/loss to understand is mean absolute error. Let's say our model makes a prediction on the prices of something, like a sandwich. Here's the actual price, here's the prediction, and here the model is off by $1, $2, and then $3. And the mean of 1, 2, and 3 is just 1 plus 2 plus 3 divided by 3. We get a mean absolute error of 2. For mean squared error, we just square the error. So 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then 1 plus 4 plus 9 divided by 3 is 4.66. And again, for error/loss, we want weights that minimize the error/loss. So hopefully we try to get these as close to 0 as possible. Now, for regression, where the output is a number, an example could be price or quantity. In fact, in the previous slide, this was regression, right? We output like a number for a price. And the error/loss you can use could be mean absolute error or mean squared error. But when it comes to classification, where the output is a class, an example could be with images where we try to predict if it's an image of a dog, a deer, or a donkey. We will use an error/loss of cross entropy loss instead. Now in this video, we will not go over the math used in cross entropy loss, but what I want you to focus on in this slide is that depending on what our model is trying to output or accomplish, you will use a different error/loss accordingly. In fact, if you look at the fcffnn.ipyb file, or the model we ran earlier on in the course, this was a classification problem. We got images of digits, and the model tries to predict if it's a picture of a 3 or a 5 or a 7. And since this is classification, we use cross entropy loss right here. So we want weights that minimize the error/loss. For ease of understanding and for teaching purposes, let's pretend our loss is y equals x minus 2 squared. If you remember from middle school or high school math, y equals x minus 2 squared will give us like this U or parabola shape, where the y-axis will be the loss. The x-axis could be our weights or weight values. So, pop quiz. What weights will give the lowest loss? If you look at this picture, to get the lowest loss of 0, we will need weight values of 2. So this was pretty easy to figure out with this picture. Yeah, the answer is 2. And we can also prove this with math, right? If x equals 2, 2 minus 2 is 0. 0 squared is 0, a loss of 0. But it's not like your model has human eyeballs and can just look at this graph. How would your model, during training, use math to find the weight values that give the lowest loss? That's what we will discuss in the next video. See you all there.